See, when we started this course, I remember the first lecture we have done was for even odd function and periodic function. So, I think because of shortage of time, I guess we could not go through relations, functions, basics of functions. So, today we will start with those topics. All right. So, today I'm going to start with relations. That is the very first chapter of NCERT, and also if one question from this chapter you can definitely expect in the JEE mains also. Am I clear? So, we will start with relations first. Can anybody tell me what is a relation? Bhagat, if you can switch on your mic, please. Bhagat?
Sir,
Yeah, please. Bhagat, speak up. What is a relation? Priya, can you switch on your mic? Anybody from JNV? All right, chalo, nobody is able to speak up, I guess. So I'll start on my own. See, if A to B are two non-empty sets, first of all, see, this is a very basic thing from the class 11th. All right, then we will move to, in like within 10 minutes, we will move to the syllabus of class 12. So if A and B are two non-empty sets, then the set of all ordered pair AB, where A belongs to A, B belongs to B, are called the Cartesian product of sets A and B. I will do it once for you. Say you have a set A as 1, 2, 3 and set B as A comma B. So what will be A cross B? A cross B will be ordered pair A comma B such that A belongs to A and B belongs to B. I should not write AB as AB are already used. Let me use X and Y. So this is the ordered pair X comma Y such that X belongs to A and Y belongs to B. So in that case, what will be your A cross B? A cross B, V is 1A, 1B, 2A, 2B, 3A, 3B. This is your Cartesian product A cross B. Now, if you want to do Cartesian product B cross A, that will be X comma Y such that X belongs to B. First element of the ordered pair that should belong to B and second element should belong to A. And Y belongs to A. So that is A comma 1, B comma 1, A comma 2, B comma 2, C comma 1 and C comma 2. So from this, it is very much clear that A cross B is not equal to B cross A. That means Cartesian product of two sets is not commutative. So the first thing is Cartesian product of two sets is not commutative. So if A and B are two non-empty sets, then the set of all ordered pair AB, where A belongs to A, B belongs to B, are called Cartesian product. Now see, one very important thing. If number of elements in set A is say P and number of elements in set B is Q, then the number of elements in the set A cross B will be PQ. If number of elements in set A is P and number of elements in set B is Q, the number of elements in A cross B will be P into Q. That's very much clear. Here you can see if A has 3 elements, B has 2 elements, then A cross B is having 1, 2, 3, 4, 5, 6, total 6 elements. Fair enough? Now, If A and B be two sets, then a relation from A to B is a subset of A cross B. There comes the definition of relation. This is what I should say. Definition of a relation. Like A and B be two sets, then a relation from A to B is a subset of A cross B. If A and B are two sets, then the relation R from A to B is a subset of A cross B. Relation R from A to B is a subset of A cross B. Let's say simply the previous A cross B I have written. It was 1A, 1B, 2A, 2B, 3A, and 3B. So say this is your set A, this is your set B. Now here elements are 1, 2, 3, here elements are AB. So simply this is a relation. This is a relation from A to B. This relation can be expressed in the form of ordered pair as 1A, 2A, 3B. That's it. Got it? So any relation from A to B is a subset of A cross B. Now, if number of elements in A, P, number of elements in B, Q, number of elements in A cross B is PQ. So number of subsets from A to B, number of subsets not from A to B, I should say number of subsets of A cross B will be 2 to the power PQ. So number of relations from A to B can be 2 to the power PQ because a relation from A to B is a subset of A cross B. So as many elements you will have in the subset or as many subsets you can have, that much number of relations we can have. Am I clear? So that is how. See, one question in JEE Mains from this particular portion is 100% sure. So make sure you attend this session very judiciously so that you will definitely crack that question. And any question from this chapter is just a treat. If a question comes from this chapter, you are definitely going to crack it. Now, what is the domain of a relation? Now, domain is what? Once a relation is defined, so the collection of first elements of the ordered pairs is what? Domain. So domain of relation R is the set of first elements of all the ordered pairs of relation R. And domain is a subset of A. It need not be A exactly. If you remember in functions, domain should be set A itself. In relation, domain can be a subset of A. Like I have a set A. I have a set A as 1, 2, 3, 4, 5, 6. I have a set B as A, B, C, D. Now the relation mapping is like this. 1 goes to B, 2 goes to B, 3 goes to B, and 5 goes to C. That's it. So how will you write this relation? The relation is 1B, 2B, 3B, and 5C. Yes or no? So what will be the domain of R? Domain of relation will be what? Collection of first elements of the ordered pairs. That is 1, 2, 3, and 5. Now comes to range. Range of R is what? Collection of second elements. Second elements are B, 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 C. And in any set, we don't repeat elements. So range is what? B, comma, C. Now codomain is like in the function. It is the entire set T. Am I clear? So domain is first collection of first elements of the relation. That is 1, 2, 3, 5. Range is B and C. Collection of second elements of the ordered pairs in the relation. And Codomain is what? Codomain is directly set B. Done? Fair enough? Now see, let's write a relation. A relation R is x comma y such that x belongs to 1, 2, 3, 5. Y is 3z minus 3x minus 1. That's it. Got it? So first of all, what is the relation? Relation is and y belongs to z ultimately. This is also given. Now see, relation is having ordered pairs x, y. So while x is 1, y is going to be 2 because y is 3x minus 1. Y is 3x minus 1. Got it? Now, while x is 2, y is going to be 5. While x is 3, x is going to be 9 minus 1, 8. And while x is 4, y is going to, sorry, while x is 5, y is going to be 15 minus 1, 14. Am I correct? Now, what is going to be the domain of this relation? Domain is 1, 2, 3, 5. Range is 2, 5, 8, 14. And codomain is what? Since y can belong to z. So codomain is what? Codomain is going to be the set of all integers. Codomain is set of all integers. Am I clear? So this was the basic recall from 11th class. A very popular question from the 11th class is on the ordered pair if they ask you ki x plus y comma 2x minus 3y, this ordered pair is equals to 1 comma 4. Find x comma y. Now see, equality in ordered pairs means their first entries are equal as well as their second entries are equal. Got it? So equality in ordered pairs is what? Their first entries is equal as well as their second entries are equal. That means x plus y is going to be 1 and 2x minus 3y is going to be 4. So if you simplify them, you get 2x plus 2y is equals to 1. Sorry, 2. If I subtract both of them, so minus 5y is 2, implies y is minus 2 by 5. So you place the value of y, you get x as 7 by 5. Got it? So that ordered pair xy that was expected from you is what? 7 by 5 comma minus 2 by 5. That's it. Am I clear? Now, this is a very important word. Mostly in 12th class, we will talking about this only. A relation on set A. A relation on set A. Generally, what we are talking as of now, a relation defined from set A to set B. Isn't it? A relation defined from set A to set B. Now they are saying relation defined on set A. That simply means a relation defined from A to A. A relation defined on set A means a relation defined from set A to set A. Is it fine? Now, relation on set A is a relation from A to A. They're repeating the same thing which I just told you. Or in other words, a relation on set A is a subset of A cross A. Definitely, if it is defined from A to A, means it is a subset of A cross A. Got it? Now, the very simple example is, let A be the set 1, 2, 3, 4. which ordered pairs are in relation? R is AB. A divides B. Find its domain and range. A divides B. Now see, it is a relation defined from 1, 2, 3, 4 to 1, 2, 3, 4. Got it? So this A cross A will be having total 16 elements. But see, in every ordered pair, first entry might not be dividing the second entry. What they are saying, A should divide B. That means now the elements in the relation can be 1, 1, 1, 2, 1, 3, 1, 4 because 1 divides every number. Now 2, 1 won't be here, 2, 2 and 2, 4. 3, 1 will not be here because 3 does not divide 1. Similarly, 3 does not divide 2. Now there will be 3, 3. Also 3, 4 won't be here because 3 does not divide 4. Now here we comes with 4, 1, 4, 2, 4, 3. None of them will be in the relation. Now there will be 4, 4. This is how we define this relation. Now domain is what? Domain is collection of first entries, that is 1, 2, 3 and 4. Range is what? Range is collection of second entries, that is also 1, 2, 3, 4. Understood? Madhukar, got it? Madhukar, so this is relation. Now types of relation. This is the most important thing is chapter identity relation. Identity relation means elements related to itself. Got it? A relation R on set A is called identity relation on A if R is A comma A belongs to A, means it is having only those elements which are related to itself. For example, if A is 1 to 1 to 4, then the identity relation on A is given by 1 1 2 2 4 4. Got it? Very simple thing. Similar to identity functions. Now, if A is 1 2 3, does following relation represents identity relation on A? Now see, 1 related to 1, 2 related to 2, 3 related to 3, but it should not be here. 3 should not be related to 1 in an identity relation. So, not an identity relation. Understood? Not an identity relation. Now, this is also not an identity relation because 3 is not related to 3. Identity relation is what? Every element should be related to itself and related to itself only. Every element should be related to itself and itself only. It should not be related to any other element. Got it? Now, universal relation is what? Universal relation is complete A cross A. Every element should be related to every other element possible. A relation R in set A is called universal relation on A if each element of A is related to every element of A. Like R is directly A cross A. If we are having a relation on set A, that means complete A cross A is the universal relation. For example, if set A is 2, 4, then the universal relation on A will be given by 2, 2, 2, 4, 4, 2, 4, 4. Every element is related to every other element. Now, void or empty relation. Void or empty relation means no element of A should be related to any element of A. Got it? That means simply phi relation. So a relation R on set A is called void or empty relation on A if no element of A is related to any element of A. So this is basically phi. For example, say if A is 1, 2, 3, 4, 5, then I write a relation A comma B, A belongs to A, B belongs to B, and A minus B is 8. Now, if you realize elements in A are having a maximum gap of 4, how can A minus B be 8? That means this relation R is going to be phi. That is empty relation. Am I clear? So this is what we call empty relation. Now, see a question. Let A be the set of all students of a girls' school. Show that the relation R in set A given by A is brother of B is an empty relation. Is it or not? First of all, tell me, is it an empty relation or not an empty relation? Anybody? Anybody who would like to answer it? Yes, Bhagat, what is the answer? Is it empty or not empty? Empty. Why so? Because they are saying A is brother of B, and since it is a girls' school, there is no boy who can be brother of any girl. There is no boy existing basically in the school. So it is an empty relation. R2 is A comma B. The difference between the heights of A and B is less than 3. Is a universal relation? Definitely. If there are two people in a girls' school or in anywhere in the globe, difference between their heights cannot be 3 meter in any case. There is no person on the globe having height 3 meters. Am I clear? So this is a universal relation because their heights is definitely going to be less than 3 meter. Got it? Now see, this is just a term. The empty relation and the universal relation on set A are respectively the smallest and the largest relation on set A. Definitely empty relation is the smallest relation, that is phi. Universal relation is the largest relation, that is directly A cross A. These relations are also called trivial relation. Just a term you need to remember, nothing much about it. These relations are also called trivial relation. Got it? Now, another important term, inverse of a relation. Inverse of a relation is simply nothing. It is represented by R inverse, and we change the ordered pair. First of all, if a relation is defined from A to B, then its inverse will be defined from B to A. Got it? And now if there is an entry x comma y in the relation, its inverse will be having an entry y comma x. Got it? So if A and B are two sets, and let R be the relation from A to set B. A and B are two sets and R be a relation from A to B, then inverse of R denoted by R inverse is the relation from B to A. Then inverse of R is denoted by R inverse and is the relation from A to B, B to A defined by this B comma A. If AB belongs to relation R. That means if I have a relation like 1, 2, 2, 4 and say 4, 6, then R inverse will be 2, 1, 4, 2, 6, 4. This is your R inverse. Got it? So if R is 1, 2, 2, 4, 4, 6, then R inverse will be 2, 1, 4, 2, 6, 4. Am I clear? Now, see, very simple example here it is. Let A be 1, 2, 3, B is A, B, C, D, R is A, 1, C, 2D, 2C from A to B. Then R inverse is what? R inverse will be A1, C1, D2, C2. Just change the ordered pairs. Got it? So domain of R will be simply what? 1, 2, 1 and 2. So that will be the range of R inverse. And range of R, that is ACD, will be domain of R inverse. Got it? Now, see a simple question. Anyways, so having a look at this question, relation R is defined on set Z of integers as xy belongs to R and x square plus y square is 25. Express R and R inverse as the set of ordered pair and hence find their respective domain. Now see, x and y are integers. Okay. So first of all, let us find the elements which will be there in the relation. Now it is, if value of x is going to be 0, value of y will be 5 or minus 5. Am I clear? Now, if value of x is going to be 1, value of y is not going to be an integer because under root of 24 is not an integer. So is that why value of x won't be 1. Now value of x is 2, no. Value of x is 3. Now if I take value of x as 3, value of y square will be 16. So value of y will be 4 and minus 4. Am I clear? Now value of x is 4. In that case, value of y square is going to be 9. So value of y is going to be 3 or 4 comma minus 3. Now if value of x is going to be 5, then y is going to be 0. And see, from all of them, now there will be value of x as negative also. So negative means value of x is minus 3. Then value of y is 4. Value of x is minus 3. Value of y is minus 4. Value of x is minus 4. Value of y is 3. Value of x is minus 4. Value of y is minus 3. And value of x is minus 5, that value of y is going to be 0. This is the complete relation now. Am I clear? Now, what is the domain? Domain is what? Domain is collection of first entries. So it is minus 5, minus 4, minus 3, 0, 3, 4, and 5. If you see, its range is also going to be same. Minus 5, minus 4, minus 3, 0, 3, 4, 5. Got it? So this is the domain. This is the range. Now R inverse is what? R inverse is just reverse the entries. So R inverse is, you can write it down. Got it? Now, see another question. A relation R from n to n is defined by R is xy. X belongs to natural number, y belongs to natural number, and y is 35 minus x cube. Now, first of all, see, if value of x is going to be minus 1, value of y is going to be 36. Am I clear? Now, when value of x is going to be 1, say 0, so I will start 0. Then up one more thing is it is belonging to natural number. Natural number means this value of x as -1 you cannot take, so reject this case. Now first value of x I am going to take as 1. In that case y will be 34. Then 2, y will be 35 minus 8. 35 minus 8 is 27. If value of x is 3, then y is 35 minus 27, 8. And if x is 4, your y is 35 minus 64, which is not an integer. Means it is an integer but not a natural number. So this relation R will be having only 3 elements, that is 134, 227 and 3 comma 8. Are you children? Got it? So 1 comma 34, 2 comma 27 and 3 comma 8. So domain is going to be what? 1, 2, 3. Range is going to be what? 34, 27 and 8. And similarly, you can define R inverse as 34, 1, 27, 2, 8, 3. Got it? So this is the inverse of the relation. Now see the simple question. Quickly do it. Mark your answer in this poll. Yes, quickly. Yes, others also contribute quickly. Very good. See, I'll just discuss it quickly. If the relation R defined from A to B follows X divides Y. So what will be the relation R? See, 2 divides 6 and 10. So there will be 2 comma 6, 2 comma 10. Only 2 elements with respect to 2. Now 3 divides 3 and 6 both. So it will be 3 comma 3, 3 comma 6. Then 4 divides none of them, 5 divides only 10, 5 comma 10. Now their inverse will be what? Inverse will be reverse of this. So it's very much clear. It is 6, 2, 10, 2, 3, 3, 6, 3 and 10, 5. So this is your answer. Got it? Simple question it is. Now see this one. A is 1, 2, 3, 4, 6. R with the relation on A defined by AB is AB belongs to A. B is exact divisible by A. B is divisible by A. See, this is easy question. You will do it. Now see this one. Set A is having 8 elements. Set B is having P elements. Total number of non-empty relation that can be defined from A to B. Yes. How many? Answer. Mark your answer in this poll. Anybody else? There will be, see, let me do very simple question it is. Set A has having 8 elements, B is in. So total number of elements in A cross B is what? 8B. So number of subsets will be 2 to the power. So total number of relations is also going to be 2 to the power 8p, but they're asking for non-empty relation. Non-empty relation means there is only one empty relation, which is null subset. So non-empty relation will be what? 2 to the power 8p minus 1. This is not the correct answer. This is written wrong. It is 2 to the power 8p minus 1. By clear? 2 to the power 8p minus 1. Now, this is the most important thing is in this chapter. If 100 questions come from this chapter, 89 questions, 90 questions from this particular portion only, that is types of relation. If a relation is reflexive or not, if a relation is symmetric or not, if a relation is transitive or not. So first of all, let's go with reflexive relation. So reflexive relation is what? A relation R inside A is called reflexive if every element of set A is related to itself. Remember, every element of A. Every element of A is related to itself. Got it? Every element of A is related to itself. There can be other elements also, like 2 can be related to 5, that's fine. But 2 should be related to 2. Every element, not a single element should be missing. Like take an example. Consider a set A as 1, 2, 3. Check if the following are reflexive or not. See, the first one is 1, 1 is here, 2, 2 is here, 3, 3 is here. So every element is related to itself. This is definitely a reflexive relation. Now, see R2, 1, 1 is here, 2, 2 is here, but 3, 3 is not here. And what did I tell you? Every element should be related to itself. So not reflexive because 3, 3 is not here. R3, yes, it is a reflexive relation. It is also an identity relation. First one, R1 is not an identity relation, but R3 is reflexive as well as an identity relation. Am I clear? Now, check whether the relation A comma B, A divides B is reflexive. Yes, it is. Why so? Because every element divides itself. So if A divides A, that means A comma A will belong to this relation for every A which belongs to set of natural numbers. So it is reflexive. Very simple. Now, symmetric relation. What is symmetric? So a relation R inside A is called symmetric if. This is very simple. See, if 2 comma 3 is in the R, 3 comma 2 should also be there in the relation. Am I clear? So if A1, A2 belongs to the relation, then A2, A1 should also belong to the relation to make this relation symmetric. Got it? So see this one. Consider set A 1, 2, 3. Check if the following relations are symmetric relations or not. See, R1 is 1, 2 is here, 2, 1 is also here. 1, 3 is here, 3, 1 is also here. So this relation is symmetric. Yes, it is not reflexive. Why? Because 1, 1 is here, neither 2, 2 nor 3, 3 is here. So it is not reflexive. Come to second one. In the second one, 1, 2 is here, 2, 1 is here. Very good. 1 3 is here, but 3 1 is not here. Got it? So symmetric, no. Reflexive, no. Now come to R3. 1 1 2 2 3 3 is here. So this relation, since there is no 1 2, for which I have to find 2 1. So this is by default symmetric. And definitely it is reflexive also, because 1 1 2 2 3 3 is here. Got it? So this relation is by default symmetric, and reflexive definitely it is. Clear? Now types of relation may there comes transitive relation. Now here it is what? Relation R on set A is called transitive if say A1, A2 belong to relation and A2, A3 also belong to relation. Then A1, A3 should also belong to relation to make it transitive. A1, A2 belongs to relation, A2, A3 belongs to relation. Then A1, A3 should also belong to this relation to make it transitive. Very simple. Now see, set A is 1, 2, 3. Got it? Now see, R1 में 1, 1 is here, 1, 2, 2, 3, 1, 3. See, 1, 2 is here, 2, 3 is here. So 1, 3 should also be there, which is here. So it is transitive. Got it? Now, is it reflexive? No, because there is no 2, 2, 3, 3. Is it symmetric? Again, no, because 1, 2 is here, but 2, 1 is not here. Done. Now see R2. 1, 1, 1, 3, 3, 2. Now see 1, 3, 3, 2 is here, but 1, 2 is not here. 1, 2. A1, A2 and A2, A3 is here, but A1, A3 is not here. So it is not transitive. Definitely not reflexive because 2, 2 is not here. Definitely not symmetric because 1, 3 is here, but 3, 1 is not here. Now see 1, 1, 2, 2, 3, 3. This relation is definitely transitive. This is quite a doubt in certain teachers also. Is it transitive? But yes, it is. Because there is no 1, 2 or 2, 3 for which I have to look for 1, 3. Getting my point? There is no 1, 2, 2, 3 for which I will look for 1, 3 to make it transitive. So it is by default transitive. If that process for checking for transitive has not yet started, that means it is by default transitive. Reflexive, yes it is. Symmetric, yes it is. So this is an equivalence relation. See, if I write another relation R4, that is say 1, 1, 2, 2, 3, 3, 1, 2. That's it. Now see, is it reflexive? Yes. Is it symmetric? No, because 1, 2 is here, but 2, 1 is not here. Is it transitive? Yes, it is. This is transitive also because 1, 2 is here, but there is no 2, 3 for which I will look for 1, 3. Transitive is what? A1, A2 should be there and A2, A3 should be there. If they are there, then A1, A3 should be there to make it transitive, which is not here. Am I clear? So it is transitive by default. Now see, show that relation R defined on set of real numbers such that R is A comma B, A more than B is transitive. Yes, it is. See, let A1 comma A2 belongs to relation implies what? A1 is more than A2 and A2 comma A3 belong to relation implies A2 more than A3. From these two, we can directly conclude that A1 is more than A3. That implies A1, A3 will also belong to relation. That means transitive relation. Got it? Now this summary is not really required because we have just covered it and you are aware of this. Now see this question. Determine whether the following relations is reflexive, symmetric or transitive. See, in such cases, best if we draw the relation or if we write the relation. So relation R is what? R is, see, if X is 1, Y is going to be 3. If X is 2, Y is going to be 6. If x is 3, y is going to be 9. If x is 4, y is going to be 12. That's it. If x is 5, y is 15, which is not there in the set A. Now, is it reflexive? Definitely not, because no 1, 1, no 2, 2, no 3, 3, no 14, 14 is here, so it is not reflexive. Is it symmetric? See, 1, 3 is here, 3, 1 is not here. Again, no. Got it? Is it transitive? Again, no, because 1, 3 is here, 3, 9 is here, but 1, comma 9 does not belong to relation. So it is not transitive. Am I clear? Now, see this one. Relation R on set n of natural number is defined by this. Now see what this relation R is. It is 1, x is 1, then y is 6. X is 2, then y is 7. X is 3, then y is 8. That's it. X is less than 4, they have provided you. Reflexive? No. Symmetric? No. Transitive. Now see, it is transitive. 1, 6 is here, but there is no 6, 5 for which I will look for 1, 5. So that process of checking for transitive has not been started. So it is by default transitive. Even if I talk you, there's a relation, say it is an empty relation. I will say this relation is not symmetric, but it will be, sorry, not reflexive, but it will be definitely symmetric and transitive. Got that? Now, determine whether the following relations are symmetric and transitive. This is what you can do. I'll do another example based on the, see, there are a few more examples over it. And they're quite in NCERT examples, but we see these kind of examples in the paper also, JEE Mains also. Now, see equivalence relation. What is it? A relation R in set A is called equivalence relation if it satisfies all three, means it is reflexive, it is symmetric, and it is transitive. Now see an example. See, let us take a real life example. A real life example of an equivalence relation is has the same birthday as. That means A comma B will belong to relation R if A and B have same birthday. Definitely it will be reflexive because everybody is having same birthday as itself. Definitely it will be symmetric because if A and B have same birthday, so B and A is also having same birthday. And similarly, it will be transitive also. All right, I'll write another example, which might not be equivalence. See, relation R is defined as A comma B. Relation is A is husband of B. Now see, is this relation reflexive? No, because nobody can be his or her own husband. Is it symmetric? Again, no. If A is husband of B, then B is not husband of A. Now, is it transitive? Yes. Why so? Because if A is husband of B, means A comma B belong to relation, then B comma C won't belong to relation because A is husband of B means B is a female. So further, B cannot be husband of anybody else. Am I clear? So A is husband of B, but B comma C won't be there. So the process of checking for transitive has not yet started. Am I clear? So this relation is by default transitive. Got it? So this is how we do these kind of questions. I insist you guys to please do some more questions on PYQs from this chapter. This is important. This is easy and this is 100% scoring. And once you do 4 or 5 questions of previous year from this chapter, you will be very much confident and through with all the things. All right. So I would like to call an end to this session. Practice more, do more. And just before leaving the session, just leave this feedback.